Okay, let's look at this example. So this example is about the concept of Newton-Raphson. Okay, so now the question is asking to sketch the graph of Ex and Y equals to X on the same coordinate axis. Right? Okay, we just sketch. I just want to tell you why they're asking you to sketch the graph. So the sketching here, usually I will asking student to really plot the graph, right, rather than just sketch. All right. So means that. So it's really go and measure the value here. If can, you're using a graph paper so that there is more accurate. All right. So 1, 2, 3, 4. All right. So then we have to sketch the graph of y equals to e to the power of x. Right. Y to the e to the power of x. So we have to see that if I know that 1 here also be 1. All right. So let's see when e is 0, when x is 0, so e will be power of 0, right? E power of 0 will be 1, right? They will intercept at 1, okay? As you know, the graph for exponent, you don't simply sketch, but we actually really need to plot some point here, at least 3 points, okay? Let's say when x is 1, right? So when x is 1, so we really go and sketch some point, plot up some points, so I can choose 0, 1, and 2, 2, okay? So we can see when 0, this is 1, when 1, so when exponent to the power of 1, so we are getting 2.7, all right? Just make it to 1 decimal places. So calculate when 2, you are getting, so e to the power of 2. So you're getting 7.4, right? 7.4. So roughly you know, where's the graph go, right? So, and for x plus y, okay, let's look at this graph. At first, we sketching this graph for exponent first, separately. So first, we sketching the graph for y equals to ex. So you know that when 0, x power of 0, e power of 0 is 1, right? So you have 2, 3, 4, 5, 6, 7, doesn't matter. So when 0 is 1, so when 0 is 1, so we know it's 1 here. So when 1, it will be 2.7, right? Roughly around here. So 2.7. So if 2.7, so sum. So we have to really measure it. We make sure it's 2.7. If you have 3, then no 7.4. So you know if you sketch the graph, it will be looking like this way. Let's say if you're sketching, if you have graph paper, you're sketching, the graph will be look like this way. All right. So instead of we simply sketch, all right, we just choose a first 3 points and we can see that this is a graph for exponent. All right. So later we sketch this graph also. Y equals to 2 minus x. The linear graph. This one is easy, right? As long as you have 2 points, so you can find the x-intercept, right? Pintasan x, x-intercept, y will be 0, right? So 2 minus x equals 0, so x will be 0. X will be 2, right? So x will be 2, so this is your x-intercept. Y-intercept will be y equals to 2 minus x, I can rewrite as mx plus c, right? mx plus c, so your c here is 2. 2 minus x is negative x plus 2, which is also 2, right? So as you see that when we're sketching the graph, you can see that the the graph for y equals to 2 minus x and the graph for y equals to exponent to the power of x, when we really go and plot some point, we can see that the two graph is actually intersect at a point, right? It's actually intersect at a point. And intersecting here means that this will be the roots of the equation, right? Because it will be the roots for this equation here, for your information. Because why? During that point, the y value will be the same, right? The y value will be the same. The information here is, once they intersect at that particular point, the y value will be the same, right? It will be getting the same value of y. So for the same value of x, same value of y, all right? So this is an intersecting point. So this is also a roots. The value of x here, is also the roots for this equation. Do you know why? Because at this value of x, the value of y are the same. this one and this one are the same, right? If this one and this one are the same, means that Ex is the same as 2 minus x at this particular value of x. So this will be your roots. But that's why they ask you to sketch the graph. It's actually indirectly tell you this will be the roots. So if you look at the roots here, the root is fall between 0 and 1, right? It's between 0 and 1. So, but we're not sure, right? We're not sure, is it 0.5? Is it 0.5? Is it 0.6? Some will say, sir, this will be 0.4. Some will say, this will be 0.6. Some will say, this will be 0.7. Or even a Superman, maybe a Superman, they can see that, oh, this one is 0.51, right? 0.51. So the accuracy is different, right? According to different people. But the actual value here, we don't know. We really don't know. But what we need to know is the Newton-Raphson method, because Newton-Raphson method can help us to achieve what is the actual value here. It's even powerful than a Superman. Alright, because it can help you find the value. Just based on the graph, you can just see the accuracy can be 0.5 or maybe 2 significant figures. But through Newton-Raphson method, you can see everything. Alright, so now based on the graph, okay, just now I talked so many because I just want to tell you the sketching of the graph here is to use to obtain the first approximation to the root. Penghampiran pertama, you will see that, oh, it like 0.5, oh, it like 0.6, oh, it like 0.7. This is called the first approximation. The first, you see, the value is nearer to some value, but it's not the actual value. So now for this case, use your graph to obtain the first approximation. You can use any. You can choose x1 to be any value you like. For me, I will choose 0.4 because from my graph I see this is like 0.4. Maybe your graph is look like 0.8. It's okay to choose any value. Alright. So in my case now, I'm going to choose x1 to be 0.4. So now I'm going to show you how to using this first approximation in getting the roots for the equation. Alright. Alright, okay, let's continue by using Newton-Raphson method, a powerful method than a Superman, alright, to finding the roots. So how you know that the Newton-Raphson formula will be writing as this way, right? To derive this formula, I'm surely both of them, Newton and Raphson, will be thinking a lot before reaching this formula, right? So, okay, how to apply this formula? This formula, you need a fx, right? As you know that from this equation, you have to modify the equation such that you're getting the fx, right? The fx. So you have to make one side become 0. So plus x minus 2 equals to 0. You're moving every unknown here, everything here, and making here become 0. So that it's become an equation that you want to solve this equation and getting the roots of this equation, right? The solution of this equation. So I rearrange ex plus x minus 2, and of course this will become my fx. So I try to let fx to be ex, right? To be ex plus x minus 2, right? Ex plus x minus 2. So then of course I need the first derivative as the formula didn't need it. So I differentiate ex, I'm getting ex, differentiate x, I'm getting 1, differentiate negative 2, I'm getting constant. So finally, I can know that for this case here, the Newton-Raphson iteration formula will be xn minus with your exn, ex to the power of x, plus x minus 2, ex power of n plus 1. So this will be my iteration formula, right? My iteration formula. So I'm going to using this formula to getting the roots, to approximate the roots. First, by choosing x1. So just now from the graph, I'm choosing 0.4, right? It's okay also if you're choosing 0.5, as long as the interval, right? Just now the graph will be intersect in between 0 and 1, right? You can choosing any value, even 0 and 1 also okay. But it's encouraged to choose in the interval between 0.1, 0.7, 0.8. You can start with any value and you can get your roots. So for me, based on my graph, I'm choosing 0.4. Alright, so now how to getting the x2? So to getting x2, I need to substitute the x1 here. So with 0.4 minus with plus with 0.4 minus 2 over with e 0.4 plus 1, right? So I have to find the value of x2. Then later, after I have my value of x2, I substitute inside here x2, I will getting x3 until the value remain unchanged. Right? Unchanged means that it's already converged, it's reached a fixed value. Then that value will be the roots of this equation. Alright, okay, let's see. I will teach you how to using calculator in finding the roots. Right, okay, let's look at the iteration formula here. We know that the iteration formula will be xn minus with e power of xn plus with xn minus 2 over with ex plus 1, right? So I'm going to key in this one into my calculator, as I need to note it down that I just need 3 significant figure. So usually if 3 significant, I will give extra to 5 significant figure, or if you want, you can give 1 extra significant figure to make sure the accuracy, okay, of the solution. So alright, okay, let's look at this. We have to key in this into your calculator, right, at first. So it will be alphabet x minus with, okay, so shift the ln here, so we have alphabet x, pressing the arrow here to bring down, so plus alphabet x minus 2, okay, then now going down, then we have e to the power of x, alphabet x, so plus 1, so plus 1. So I have key in already exactly the same. Make sure this is correctly. Okay, then I'm pressing the button calculate. Okay, now it's the time for me to see what is the value of x1, right? The first approximation here will be 0.4, right? So of course, I want to find the value of x2. I have to substitute the 0.4 into the equation. Right, into the equation 0.4 here. If you key in every time, it will be consume time, yes or not? You want to find x2. So for me, I already using calculator, the technology to apply. So now I want to find x2, very simple. Okay, I want to find x2. So I just pressing calculate 0.4, right? 0.4. So then you press double equal 1 time, 2 time. Then you will get your x2. So they want 3 significant figures, so we give 5 significant figure to make sure it's accurate. 4, 4, 3, 4, 1, right? 4, 4, 3, 4, 1. So now this is your x2. Now we have to see to get x3, and this is not the same, right? They are changing. So we continue. So calculate the answer, right? Then we're pressing equal, double equal. So we're getting 0.444285, right? 0.444285. So, okay, it's still not the same because, okay, let's see. I think it's already the same because they want 3 significant figure, right? So 0.443, if you round off, you're getting 0.443. If you round off this also, you are getting 0.443. This 2 value here is already reaching the same value, right? They're already reaching the same value here. So means that it's already remain constant after you round off, right? So means that 0.443 will be the solution for this problem, right? But if you don't trust it, you can still continue. Calculate answer, right? Calculate answer, then pressing double equal. You will get 0.44285. Right? If you calculate answer again, equal, double equal, you will still get 0.44285 because why? It's already constant, right? But I will just stop here because why? After I round off, this is also 0.443. So it means that the solution for this problem will be 0.443. This is the roots for this problem here. So very simple, right? So okay, let's back to how to writing the step. Alright, okay, now you have your x2, which is 0.44341. Right? So now go for x3, as you need to put the value of x2 into the iteration formula to get x3. Right? So you have to 0.44341 minus with e 0.44341 plus with 0.44341 minus 2 e 0.3344341 plus 1. Okay, showing that you are using the iteration formula. So then you still have from the result just now, you have getting 0.44285, right? So I stop here. I'm stopping here because why? Because the value after I round off, I was getting 0.443. This is also around 443. So they already remain constant after round off. So the solution for this problem is 0.443, right? 0.443 will be the roots of this equation, right? This is powerful compared to Superman. Why? Because just now, when we're sketching, right? When we're sketching, I've already tell you, when we're sketching, we just can know that the value is between 0.1, right? Some will say 0.5, some will say 0.7, some will say 0.4. Alright, for me I said 0.4 because it's nearly like less than half of the interval, right? But surprisingly, after apply Newton-Raphson method, this is even more accurate, 0.443, which human can't see what is happening here. I just can see 0.4, but actually it's 0.443. So the accuracy is there. So means that the roots of this equation will be 0.443 by applying Newton-Raphson method. Alright, hope you understand why we use Newton-Raphson method rather than just sketching the graph and see the roots. Because accuracy. Alright, okay, see you